Hi, this is Jay Haskamp, and I'd like to welcome you to another Tech Talk by Frontier Precision. Today's session, we're going to take an in-depth look at how to create and/or edit a conventional survey style. In the main Trimble Access screen, we're going to locate the Settings button, and then in Settings, we're going to select Survey Styles. Now, by default, you will see a VX and S Series survey style that is loaded in Trimble Access. If you're using a VX and an S Series instrument, you can pick this style and modify as necessary. However, typically the system defaults are sufficient. But if we want to make a new survey style, we're going to back out and we're going to pick the new soft key on the bottom of the screen. And for a style name, we will just call it conventional. And our style type, we will choose conventional. GNSS is if we're using a GPS or a GNSS receiver. Conventional is for any and all total stations, robotic or otherwise, and integrated surveying is for the combination of both GNSS and total station work. So for this example, we'll pick conventional and pick accept. Now we are taken to the conventional survey style settings. You can see here we have instrument, Topo Point, Stakeout, duplicate point tolerance, laser rangefinder, and echo sounder settings that we can modify. First, we'll start with instrument. The first thing we want to do is look under the manufacturer. By default, we will see Trimble, and for the model, we'll see VX/S Series selected. However, we can hit the pull down and notice that we can use other manufacturers' total stations as well. So you can see here we have Trimble, Leica, Nikon, Pentax, Nokia, Spectra Precision or Geodometer, Topcon, and then lastly we have manual. Manual is what we're going to use if we want to manually key in any types of measurements by hand. Also, one thing you want to do when you're using a non-Trimble instrument is disable the Auto Connect options in Trimble Access. Some commands used by Auto Connect can interfere with the communication of non-Trimble instruments. For additional setup information for non-Trimble instruments, refer to the onboard help file by pressing the question mark button in the upper right-hand corner of the screen in Trimble Access. If we're using an instrument other than a VX/S series, for example if we choose Nikon, notice we now have connection settings such as the baud rate and the parity. Use the baud rate field to configure the general survey baud rate to match that of the conventional instrument you're trying to connect to, as well as the parity field. If these two settings match your instrument, Trimble Access should connect to them with no issues. When you change the instrument type, the baud rate and the parity settings automatically change to the default settings for the selected instrument. For an example, if I switch from Nikon to Topcon, notice the baud rate changed from 4800 to 1200, and also it provided some specific models to that particular manufacturer. If we switch it back to Nikon, we also have some other settings we need to take a look at. The next setting is the horizontal angle, vertical angle status rate. Use the HAVA status rate field to set how often the general survey software updates the horizontal and vertical angle display in the status line with the information from the conventional instrument. One thing to note is that some instruments beep when communicating with the general survey software. You can turn off the beep in the instrument or set the HAVA status rate to never by picking the little right arrow and selecting never. We will also see a measurement mode. The measurement mode field appears if the selected instrument type has more than one measurement mode that can be set by general survey. Use this mode to specify how the EDM measures distances, and options are going to vary according to the instrument type. Some instruments may also have an instrument default option to always use the specific setting that is set on the instrument itself. Now, if we go back to the Trimble manufacturer and we configure this for a VX/S series instrument, notice we have our measurement mode as well for the Trimble total stations, but now we also have an average observations setting that we can change here. So we're going to use the average observations method to increase the measurement precision with a predefined number of observations. The default for a VX and S series instrument is 5 averaged observations. We can change this if desired. Then down below we have the auto F1, F2, which stands for Phase 1 and Phase 2. When using a servo or robotic instrument, we can select the Auto Phase 1, Phase 2 checkbox to automatically measure a point or stakeout position on Phase 2 after it's been measured on Phase 1. One thing to note is the Auto Phase 1, Phase 2 functionality is not suitable for use when you're staking with the 5600 using AutoLock, as the 5600 is not able to operate the EDM in tracking mode on Phase 2. Also, when auto phase 1, phase 2 is selected, once the phase 1 measurement is completed, the instrument automatically turns to phase 2. The point name, however, does not change, which allows the phase 2 observation to be measured with the same point as the phase 1 observation. Once the phase 2 measurement is completed, the instrument will then return back to phase 1. Also, the auto phase 1, phase 2 does not work when starting on phase 2 or when the measurement method is either set to an angle offset, some type of a distance offset, a dual prism offset, a circular object, or a remote object. You can see here in newer versions of Trimble Access, we can specify what specific types of measurements we want the system to use the auto phase 1, phase 2 option. Then down below we have the measure distance on phase 2. This option is used when you're measuring topo when auto phase 1, phase 2 is selected, or if we measure rounds, do a station setup plus, or a resection when a distance observation is not required on phase 2. When the measure distance on phase 2 option is selected, if the phase 1 measurement method included a distance measurement, then the measurement method for phase 2 is automatically set to angles only after the phase 1 measurement. After the phase 2 measurement, the instrument returns to the method used on phase 1. We also have the option to turn auto lock on or off for offsets if we're doing offset shots. Now you can see we also have a set backsight option. The set backsight field will appear if you can set the horizontal circle reading on the instrument when the backsight is observed. The options are 0, no, and azimuth. If you select the azimuth option, when you observe the backsight, the horizontal circle reading is set to the computed azimuth between the instrument point and the backsight point. Servo auto turn is another option that we have. And when we're using the servo instrument, the servo auto turn field in the survey style can either be set to horizontal and vertical angle, horizontal angle only, or off. If we select horizontal angle and vertical angle, or horizontal angle only, the instrument automatically turns to the point during the stakeout, and when a known point is entered into the point name field. If you are working robotically, or when the servo auto turn field in the survey style is set to off, the instrument does not turn automatically. To turn the instrument to the angle indicated on the screen, you will tap Turn on the screen. Moving on to page 2 of the settings, we also have an instrument centering error and a backsight centering error option that we can modify. The centering error is used to compute the observation weights as part of the standard resection and station setup plus computations. Also, we have an Edit Instrument Precisions checkbox that if we check, you can see we have an instrument precision setting box that appears on the screen. So we're going to use the instrument precision fields to record the precisions of the instrument. So we can do one of the following. We can leave them all as null. We can enter in the manufacturer's values. We can accept the default values, or we can enter our own values based on our observing techniques. If we leave all the fields set to null, the statistics are computed using Trimble Business Center default values. If you enter values, they are used to weight observations in the calculation of the mean orientation and scale factor for multiple backsights and resections, as well as a resected position. They're also used in Trimble Business Center to compute the standard error statistics from an observation. If we're going to use a Trimble VXS Series total station or a Trimble 5600, the instrument precisions are not configured in the survey style. General Survey will read the instrument precisions from the instrument. These precisions are then used to weight and calculate the standard error statistics for an observation. Observation standard error statistics are stored with each observation, and the standard errors can be used in the Office software to weight the observations during the network adjustment. So in this example, we're configuring this for a Trimble VXS Series total station, which means we can uncheck the box because the precisions will be read from the instrument. Also, for a conventional survey, the Stakeout graphical display screen will display directions using the conventional instrument as a reference point. So for a conventional survey, we can configure the Stakeout Directions and the display mode of the graphical display when we're staking in the field. The Offset and Stakeout Directions allows us to configure the Stakeout Directions to either be from an instrument perspective, from target perspective, or to be automatic. Automatic configuration sets the stakeout directions automatically based on whether you have a servo connection or robotic connection to the instrument. Once we're satisfied with our changes, here we can hit accept, and those are the instrument settings. Now we're going to move on to Topo Point. The Topo Point settings are very basic. Basically, we have what we want displayed on our measurement. The default is the horizontal angle, the vertical angle, and the slope distance. These are going to be the defaults, however, these can be changed during the survey. Auto point step size by default is set to 1. This simply means that when we measure a point, the next available point in the sequence will be the next point number. It will not skip any numbers unless they are previously taken. And view before storage means that once we take a measurement, we will get an extra screen showing our measurement, our precision values, and our angles and distances before we pick store to actually complete storing the measurement. We can accept that, and now we can move to Stakeout. In the Stakeout screen, there are a lot of settings. The first setting is view before storage. What this means is when you stake out a point, a line, or an object, when you get to that position and before you store it, you will be prompted with an additional screen that will show you the deltas, maybe the station offset and some of the other information depending upon what you're staking. If you leave the view before storage box checked, all these other deltas format pull-down menus are things that you can change to tell the software what you want to see when you're staking. So for example, if I'm staking a road here and I leave this set to default, if I measure my point and I accept the measurement, I will get a screen showing my station, my offset, my cutter fill, and a bunch of different information related to that road. However, if I want to simplify that and I'm only interested in maybe station, offset, and cutter fill, I can hit this pull down menu and I can look for road stake markup. So this is just going to tell me what I would put on a stake for staking a road. So I have different options here for each one of these different categories, and I can modify what I see on the screen. Also, by default, the horizontal tolerance is going to be set to 0. So what this means is no matter how close I am to my point of interest that I'm staking, unless I'm exactly 0, I am going to get a screen that I can view to see how well I fit with my stakeout. Also down below, I have an as staked name setting. I have two options here. I have auto point name, which means I can enter in the point name, or it's just going to continue to use my numbering sequence in my project, or I can have it be the design name, meaning if I'm going to stake out point 42 in my design, my as staked point will be stored as point 42. So you can set the setting here how you wish to use. And then the as staked code, I have some options here. I can have my as staked code be the name of the design point. I can use the same code as the design point. I can choose last code used, which means that I have the ability to just enter in whatever feature code I wish. Or maybe if I'm doing a linear type of a stakeout, I can have my feature code of my as staked point be the design, station, and offset. Then we have store grid deltas. It's a checkbox on the bottom. The store grid deltas checkbox will basically do one of the following. If we select the checkbox, we will display and store the delta northing, delta easting, and delta elevation during stakeout. If we clear the checkbox, we'll display and store the deltas as a horizontal distance, a vertical distance, and an azimuth. And one thing to note is if you're going to use a user-defined stakeout report, the store grid deltas option is not used unless it's referenced in your actual report. Moving on to page 2, you can see we have a setting for display mode. We have direction and distance and in, out, left, right. So when the display mode is set to direction and distance, the navigation screen will display a large arrow pointing in the direction that you have to move, and then when you're close to the point, the arrow will change to the in, out, left, right directions relative to the instrument. When the display mode is set to in, out, left, right, the navigation screen displays in, out, left, right directions with the conventional instrument as a reference point. Next, we want to choose a setting in both the deltas points and the deltas other fields. The two deltas fields allow you to configure one deltas default for point stakeout and the other deltas default for arc, line, alignment, and road stakeout. So we look at our options here. If we choose distances, it's going to navigate to a point using distance only. If we choose angle and distance, it's going to navigate to a point using an azimuth or an angle and a distance. If we choose delta grid, it's going to navigate to a point using delta grid values, so maybe in, out, left, right, or go north, go east, that type of thing. And then station and offset is going to navigate to a point using a station and offset when staking a line or an arc. So when we're staking a line or an arc, the station and offset view displays the station, the horizontal offset, vertical distance, and the grade. For staking to the station on the line or arc, or the station offset from a line or arc, the view displays the station, horizontal offset, vertical distance, delta station, and delta horizontal offset. We're going to use the distance tolerance field to specify the allowable error and distance. If the target that we're trying to stake and that we measure is within the distance from the point, the graphical stakeout display indicates that the distance is correct. As well as with the angle tolerance field, this specifies the allowable error in the angle. So if the conventional instrument is turned away from the point by less than this specified angle, the graphical stakeout display indicates that the angle is correct. Also, if a DTM file has been transferred to the general survey software, we can select to display our cutter fill to the DTM with this checkbox, and the graphical display screen will then display the cutter field relative to that DTM. The DTM field will specify the name of the DTM that we wish to use, and if necessary, we can also specify a vertical offset to the selected DTM. One thing to make note of is that all the DTM files from all folders on the controller will be listed in this pull-down menu. The last two settings here are to use tracking mode for stakeout. This is ideal as tracking mode is continually measuring you as you move and will give you real-time updated angles and distances and directions as you're moving along. This will be with a gun that has the auto lock capability. And then remove staked point from list means that if we build a stakeout list of points, as we stake and store the points, they will then be removed from the list. So we can narrow our list down to just the points that we have left. If we're happy with what we see here, we can pick accept. The next section here is duplicate point tolerance. We have some different settings here. So for an example, if we're going to do a conventional survey and we attempt to add a point name that already exists, no message is going to appear to warn us that the point already exists like we would normally see with a GNSS survey. This is because we may want to regularly measure points on both faces. In a real-time GNSS survey or a conventional survey, we can set the tolerance for a duplicate point warning. So we can specify the maximum distance that a new point can be from an existing point, both horizontally and vertically. And then a duplicate point warning appears when you try to store a new point, only if it is a duplicate point outside of the tolerances that we set. If the new point has the same name as an existing point, and it is closer to the existing point than the specified tolerances in our survey style, the point is then stored as a new point and does not overwrite the existing point. When we select the auto average option in the survey style right here, the point is stored as a new point, and an average of all previous positions of the same name is also stored. An average position will have a higher search class than a normal observation. If the new point is further from the original point than the tolerance is specified, you can choose what to do with the new point when you store it. So our options are going to be to discard the point, to rename the point, overwrite the point, which will delete the original point and all other points of the same name and the same or lower search class. We can store as a check, which will store with a lower classification. We can store and reorient, and this option will basically only appear if you're observing a backside point. What this will do is store another observation that will provide a newer orientation for subsequent points measured in the current station setup, but previous observations will not be changed. We can also store as another, which will store the point that can then be averaged in the office software, and the original point is used in preference to this point. And then we can average, so we can store the point and then compute the stored averaged position. There's also two averaging methods that are supported in Trimble Access, either a weighted or an unweighted calculation, and we can set the averaging method under the COGO settings screen in our job setup. One thing to note is that when you select to average the points, the current observation is stored and the computed average position appears along with the computed standard deviations for the north, east, and elevation coordinates. If there are more than two positions for the point, the details soft key appears and we can tap the details to view the residuals from the average position to each individual position. You can then use the residuals form to include or exclude specific positions from the average computation. Also note that when an auto average option is checked and an observation to a duplicate point is within the specified point tolerances, the observation and then computed average position using all the available point positions are automatically stored. The general survey software computes an average coordinate by averaging the grid coordinates computed from the underlying coordinates or observations. Observations that do not allow grid coordinate to be resolved, for example, maybe an angle-only observation, are not going to be included in the average coordinates. And then lastly, we have the phase 1, phase 2 observation tolerance. So when we carry out a double-phased observation in a conventional survey during our station setup plus, resection, or when we're measuring rounds, the general survey software will check that the phase 1 and the phase 2 observations to a point are within these preset tolerances. If the observations are out of tolerance, the observation out of tolerance screen will appear, and the screen will display the following options. We'll get the option to discard the observation without storing. We will be able to rename to a different point name. We'll be able to overwrite and delete the original point and all other points of the same name and same or lower class. We'll be able to store with a check classification, or we'll be able to store the observation as another. And once we've completed the station setup plus, resection, or round measurements, the general survey software saves the mean turned angle to each of the observation points, and the software does not check for duplicate points at this stage. Therefore, to use any of the observations to compute an average position for an observed point, you must select the Compute Average option from the COGO menu. So, with that said, our duplicate point tolerances we're going to leave set at the defaults. Now that we know what they all do, and we're going to pick Accept. The last two options here are Laser Rangefinder. This is if we wish to use a third-party laser distance device. For example, maybe a TruePulse 360B, and when I select it, you can see all of the connection and precision settings show up here that I can set per the manufacturer's requirements. And same with the echo sounder. I can run, say, a Sonar Mite echo sounder in conjunction with my total station to get depths of maybe a creek bed or a lake. And again, once I choose my manufacturer, my type, I have the connection and the latency settings that I can select here. Once everything looks good, we simply hit the Store button to save the changes, and now we're ready to survey with our conventional survey style. And that concludes our Tech Talk on creating or editing a conventional survey style. Hope that you found this beneficial, and will join us again next time. Thank you.